Today, companies rely on log data to drive growth. For instance, internet services log any searches a user enters, any items the user clicks on, and then analyze the logs to recommend other items the user might be interested in. Logs also contain debug and audit information from critical points in the system's execution. By analyzing this log data, companies can improve their product and user experience, minimize system downtime, and optimize resource usage. The log data is really a goldmine of insights and opportunities. Therefore, many companies generate petabytes of logs per day, and this size is growing furiously. But storing and analyzing logs at this scale is costly because it requires a lot of storage and compute resources. Of course, compressing the logs can alleviate some of this cost, but then analysis requires decompression, which is still impractical at this scale. So companies can only keep recent logs accessible for a short amount of time. Any older logs are either archived after being compressed or are simply thrown away. In either case, the insights from these logs are now gone forever, together with any opportunities for growth or optimization. As a company grows, the problem only gets worse as the retention period shrinks further and further. Thus, archiving and analyzing logs are unfortunately mutually exclusive. But with CLP, they no longer have to be. CLP, or Compressed Log Processor, is a log analytics tool for compressed logs. By using our innovative algorithm, CLP achieves a compression ratio of more than 40:1. This is 2 times higher than the default compression tool, gzip. Furthermore, users can directly search and perform complex analyses on the compressed logs without decompression. This means that searching the logs uses 40 times less computing resources with CLP. So let's see CLP in action. This is CLP's web interface for an instance running in our cloud. We can ingest logs directly from Amazon S3 by entering the S3 bucket information. As the dashboard shows, CLP is compressing the logs at 1 gigabyte per second, which is over 10 times faster than competing tools. And we can immediately search the part that was already ingested without waiting for all the logs to finish compressing. When the ingestion finishes, the compressed log is only 328 gigabytes. That's 2.26% of the original size. Now let's say we wanted to search for error logs related to containers. We could enter a query, error star container. CLP supports wildcard queries, so we can enter the star wildcard to match any number of characters. Right now, CLP is searching the compressed logs and only decompresses matching results. This graph shows the distribution of results over time. We can see a lot of error messages. Many are repetitive. So what if we wanted a list of unique container IDs that experienced errors? For this, CLP supports piping results between operators. We can parse the container ID by first piping results to a regular expression operator. So we have the regex keyword, and then this expression captures the container ID and saves it in a field called container. Then, we pipe these results to the unique operator, and it returns a list of unique container IDs that experienced errors. Besides the web UI, users can also script these queries using CLP's APIs. And CLP also provides a fully featured Linux terminal where we can browse the compressed logs as if they were not compressed. For example, we can navigate the directories and use find to look for specific logs. And we can open a file and it will be transparently decompressed. Thus, with CLP, no opportunity is lost. Users can store their entire history of logs, efficiently search all of them, and they can even afford to log much more, all at a fraction of the cost of their existing solutions. So CLP bridges the gap between archiving and analytics, enabling what we like to call archivalytics.